so we're going to use this alternative variance formula to calculate the variance of this probability distribution right here. And I'm not going to move too slowly through this because it's relatively straightforward. Now, first up, we want to calculate the expected value, because this part of the formula right here is the expected value. And we know how to find expected values. That's easy. Right, so you can see it's straightforward here. Do it the same way you've always done it, and you get an expected value of 2. Now, the other part of this variance formula is the expected value of x squared. Now, the way that I like to do this is to insert an extra row in my table. Extra row, the x squared row. And then I just take all of my x values and square them. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then I just create another expected value formula, but this time ex squared. It's going to look similar to the other one to begin with, because I'm still doing 0 times 0.08. I'm still doing 1 times 0.18. Instead of 2 times 0.4 like the last one, it's going to be 4 times 0.4. And instead of 3 times 0.34, it's going to be 9 times 0.34. When I do that, I get an expected value of x squared of 4.84. And finally, I can finish this all off by putting these two numbers into my variance formula. And that's really as simple as it is. Let's just get my pen out and finish this off. So the variance is going to be equal to, let's look at our formula, ex squared. Now this is ex squared here, 4.84. And then minus the expected value squared. So the expected value is 2, but don't forget that we're squaring it. 4.84 minus the expected value squared. That's going to be minus 4. So 4.84 minus 4 is 0.84. And that is the variance. You can see this is a pretty nice way of finding the variance of a discrete random